at one end of the road and one telephone pole at the other end of the road. And can you put the other telephone poles in a straight line?
As we move, the world about us changes in appearance. Objects look different from different viewpoints, and the spatial locations of objects seem to change. From one view, an object may be in front, and from another to the side. Jean Piaget has shown that it is not until middle childhood that children understand how things will look from different views. Only gradually does the child come to coordinate spatial relations such as left and right, in front and behind, up and down. As a result, the child's conception of space is inconsistent and filled with surprises for the observant adult. We begin with an exploration of straight lines, showing the gradual understanding that a straight line must appear straight from all possible views.
Claire, could you come over here where I am for a minute?
Why do I?
Come over here where I am a minute. Okay? Look at the telephone poles. Does that look like a straight line to you? No? You think you could fix it? Okay.
Marching up that way.
No. I had a road go right along here. Right here. And this phone, wait a minute, this telephone pole was right. That's at one end. And this telephone pole is at the other end. And I ask you to put the ones in between in a straight line.
4-year-old Claire has difficulty making a line that is straight and at the same time reaching its target. To do so requires simultaneous consideration of beginning and end points.
Okay, fine. One more road and we're through, okay?
Okay.
Here we go. Right along, let me take them over here.
Oh, I love you.
Put all of these over here.
I love you.
I love you too. Claire, now there's another road and it's right here.
Okay,
Now,
this
let me put the first one and the last one down for you.
that right there.
Right there and right there. Now, can you put the other phone poles in a straight line in between?
We have to make that like that, right?
Okay.
I have to. There. 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 There you go.
Okay, could you come over here and look at this from where I am? Does that look like a straight line to you or a curvy line? Look at your phone poles.
A straight line.
That's a straight line? Okay.
The fact that the line looks less straight from the ends than from the sides does not lead Claire to alter its form. This shows the different views of the same thing are not yet coordinated in her concept of straight lines.
They're going that way.
What show means? How you mean?
They're going that way. All of them going this way. All that way.
Okay, but how do you know that they're straight? How do you know that they're all lined up?
I put them in a line.
Okay. Now let me ask you, would it be better to look at it from where you are or to come and look at it from over here to see whether it's straight or not? Which would be the best place?
Right here.
From right where you are? Okay, but why don't you come over here and try looking at it? Get up from your chair.
Stacy is almost 7 and in the intuitive stage of mental development. He feels that looking at the line from where it was constructed is the best way to tell if it is straight.
Put this one back on. And tell me what you think. Is it a nice straight row?
Oh, nothing from here.
Where's wrong? What's wrong?
It's too crooked.
Okay, can you fix it for me?
When sighting down the line, Stacy finds some errors, even though from a side view the poles seem to form a straight line.
One is crooked.
Which one? Okay, fix it up.
And this one. Now they straight.
Are they all straight now? Are you sure?
Mm-hmm.
Okay, very good. Let's make another one this time, okay? This time, I want you to make a road between this telephone pole and this telephone pole, using all the rest of these. Okay? Nice straight road.
Mm.
Okay? Make a nice straight road for me.
It reached.
Okay, and is it a straight road?
Mm-hmm.
Show me that it's straight. Show me how you know that it's straight.
It's straight.
How do you know?
Everyone's going this way.
Okay, is there some place you could look to tell?
Right here.
What if you come and look down here at this end? Why don't you come and look at this end again and see if that helps you tell?
Yep.
Look down there real close. Get right down and look at it real close.
Yes. It's a little crooked
Where is it crooked?
from all of them.
Can you straighten it out more for me?
Stacy again discovers errors in his construction. This discovery, however, does not lead to an awareness that viewing a line from the ends gives a proof of its straightness, nor does it affect the way he constructs a new line.
And I want it to be absolutely straight. Now you can get up and move around. You don't have to stay in your chair if you don't want to. I'll put these over here so you can reach them.
As with the younger children, 7.5-year-old Tanya curves the developing line to meet the last pole. However, she has reached the concrete operational stage and knows that the points on a straight line must line up when viewed from the ends.
Okay, is that a straight line?
Mm-hmm.
Is it perfectly straight?
Mm-hmm.
How could you tell? Is there some place that you could look that would tell you whether or not it's perfectly straight or not? Let's see.
Over here.
Well, show me then.
Tanya's decision to look down the line suggests that she can anticipate how the line should look from different viewpoints. She knows that if the line is straight, the poles will tend to hide each other when viewed from the ends.
Where is it a little bit curved? Where is it curved?
Over here.
Can you fix it for me? Okay.
Okay. Now, Shauna, we're going to go for a little walk. We'll take
In the mountain problem, we explore the gradual understanding of left-right and foreground-background orientations. An understanding of these relations makes it possible to know how changes in viewpoint will affect changes in appearance. 4-year-old Shauna is asked to select the picture that shows how the mountains look from where she is standing.
Okay, now, you want to stand up again and take a look at these pictures. And what picture shows what the little man sees from right here? What picture shows what he sees from there? You think this one does? Well, let's take a look and see. Let's take a look at this one and see. Whoops, I dropped it. Let's take a look and see. Okay, come on, right down where he is, right here. Okay, now, what do you see there in this picture?
A boat.
Uh-huh, can you see the boat from where you are now?
Yeah.
Look, up at the mountains. Can you see the boat? No. Would you say this picture? Is this the picture he took? You think he could see all those things from here?
Like most children in the preconceptual stage, Shauna does not understand spatial relations. She sees mountains, and it is enough that the picture show mountains. Shauna lacks the means of analyzing their relative position. This lack of correspondence between the picture and model does not concern her.
You want to try this
See,
picture?
he took the picture of the boat.
He saw the...
Boat. And that's the picture.
Is this the right one?
Mm-hmm.
Now, what if somebody said they didn't believe that that was the right one? How would you convince them that that was the right one? Is there some way you could show them? How?
I take another picture of one.
Take another picture and see if it compares to that?
Mm-hmm.
You want to do that? That sounds like a very good idea. Why don't we go over there and look ourselves and see if that's right? All right, take your...
7-year-old Stacy knows that the little man can see the total boat. This allows him to select the correct picture without having to consider the mountains.
Mm-hmm.
Why don't you turn the picture around so you can see it real good like that? Is that what you see?
You see the brown one? The bird. See? Yep.
Yeah, it sure is. I think that's it. Okay, come on back. And we'll do something else. This time, we'll do just one last one. Okay? The dog goes walking right over here. See where he is? And he takes a picture. Okay?
Takes 3 of them.
Just one picture.
One,
Well, a picture, yes, one picture, but maybe of the 3 mountains.
I think the 3 mountains.
Okay, now, which one of those pictures is it? That's the problem for you to
Did
figure
he see the boat?
You have to figure that out. You stay right there where you are and try to figure it out from here.
He just saw the sign. He saw the front of the window. He saw the whole thing of the boat.
He sees the whole boat.
And then he stand from right here.
He's standing over there.
Uh-huh.
Uh-huh. Why do you say he's standing over there?
He took the picture from over there, from here, from the green one, the red one, to the brown one.
Okay. So he took the picture from over here next to the brown one, you're saying?
To the green one, to the red one.
Okay. Should we go over and check and see if that's the right photograph? Let's do that. Let's go check and see if that's the right one. Bring your picture with you. And come over here and look very carefully from right here and see.
That's the right thing.
How about if you turn around?
Here, Stacy's reliance on how the boat would look misleads him. Not being able to anticipate the changes in left-right orientation of the mountains, he selects the wrong picture. The character of spatial reasoning is also revealed in this drawing task. Like Stacy, Miles is in the intuitive stage.
Very good. Okay. Now, here's our little man. Comes over here and he looks at it. And now I'd like you to draw for me what the little man sees. So it's just like how the little man sees it now.
While Miles correctly represents his view of the block and ball, he does not coordinate the left-right changes brought about by an opposite view.
Very nice. Now, are you sure the little man sees the block on this side and the ball on this side? Do you want to check?
Because look, let's go straight up here.
And is that the way he sees it?
Uh-huh.
Do you want to go over and take a look and see? Okay, let's go over and take a look and see. Should we take the picture with us so we can tell? Okay, look and see. How did you draw the picture? Like that?
No, look like this, yeah.
Is it like that?
Yep.
All right. Very good. Now, what I'm going to do is have the man take another little walk.
Shelley is almost 8 and entering the concrete operational stage. She can coordinate left-right and foreground-background relationships to justify her choices.
Put him right there.
Okay. I think that would be this one.
I think it would be that one. Are you sure about that?
Yes, because that's like he was taking the same walk he did when we had it moved this way.
She can mentally rotate the model to visualize the opposite viewpoint.
She said you have to tell me why it's the right one. What would you tell her?
I would tell her that this one
Yeah.
is in the front ground, right?
And should it be in the front ground for the little man?
Mm-hmm.
Okay, good.
And then this, if the little man was where we are, but still in the same position with the table, you know, then this would be here.
Okay, okay.
And so the red mountain would be over here.
Uh-huh,
And the little man sees this right thing coming down on the red mountain.
uh-huh. Do we see that right thing coming down the red mountain?
No, but
But
he would.
Okay, Kevin, we're going to do some things today with this jar of water. Can you point to the water in the jar? Okay, can you show me the top of the water? Where's the top of the water? Can you show me the line that it makes? That's right. Okay, you see that line it makes? Now, watch what happens to that water when I move the jar. Can you watch what happens to the water and especially that water line? Okay. Okay.
The gradual development of spatial concepts is clearly shown in the water level task. To know that water remains level even if its container is tilted requires more than copying what one sees. In addition to vision, it requires coordinating vertical and horizontal relationships. Without this, it is impossible to know that water remains level.
Okay. Now, do you see where the top of this block is? Under the jar? Could you draw the top of the block in this picture for me?
This one?
Yes. The whole top of the block? Okay. Now, do you see the water line?
Uh-huh.
See the water line? Could you draw the water line for me in this jar?
My water line goes around.
Oh, the water line goes around? Well, I need you to show me the water line inside the jar. And I need you to look at this water line first. And make this water line the same as your water line. Okay? And where is the water?
Kevin manages to draw the water inside the jar, but he cannot represent its surface, nor can he orient the water with respect to the jar. What he draws bears little relation to what he sees. Kevin's second drawing shows that he is careful and precise in his artistic activity. Yet his visual and motor skills are not enough to overcome his lack of understanding.
Are you through now? Now, is the water in your jar the same as the water in your jar, the same as the water in this jar? Same? Okay.
In this final drawing, we again see Kevin's inability to represent the water's surface or its orientation. Children in the preconceptual stage do know, however, that the water is inside the jar.
Okay, does the water in your picture look like the water in the jar?
And I'm going to tilt the jar so it looks like it does in the picture. And draw on the table for me first, Brock. Show me where the table
Using
is.
the edge of the paper as a guide, 6-year-old Brock draws in the tabletop.
And now, can you show me what the water will look like in the jar?
During the intuitive stage, there is a partial coordination of vertical and horizontal orientations. This coordination results in the ability to interpret and draw straight lines. It likewise makes it possible for Brock to know that the hidden surface changes its orientation to the sides of the jar as it is tilted. However, this coordination is still incomplete, and he draws the water at a slope to his drawing of the tabletop.
Okay, very good.
Let's look again, okay?
7-year-old Bibi is also in the intuitive stage.
Okay, why do you think this is the right one, Bibi?
Because it's tilting like this.
And is that how the water would look?
Wait a minute. This one. This one.
You think it's that one? Why do you think it's that one?
Oh, that is right.
Okay.
In a minute. Now where?
You think it's that one?
Uh-huh.
Why is it that one, Bibi?
Because I see it tilting like that.
And is that how the water would look? Why would the water be like that?
Because
Okay. Tell me again, Bibi, why these two are the same?
it isn't.
Oh, it isn't now.
Because the little one has to be here.
What do you mean by that?
The big one, the big thing is supposed to be here. The little is supposed to be here.
Bibi does not understand the
Okay,
changes
can you find
caused
one
by
like
tilting
that?
the jar. The use of pictures shows that the problem involves understanding rather than artistic
Okay, why is
skill.
it that one?
Because the water's down like that one and it's big like that one.
Alrighty.
Can you point to how the water line goes around the jar?
Mm-hmm.
Okay, show me. Just like this, see? There it is there. Okay, that's good. Now, what do you think is going to happen to the water line when I tilt the jar? What do you think it'll do? Will the water line move? Let's tilt the jar. Is it moving? It's not moving, huh? Okay. What's moving?
The jar.
The jar's moving, huh? Now what I'm
Tanya is almost 8
Yes.
and in the concrete
And we're gonna put the
operational
right
stage
one.
of development.
Pictures that show the way
She
it
knows that
moves
the
here.
water line does not move when the jar is
Now
tilted.
I have some other
This is a
pictures.
clear indication that she has achieved an
I'm gonna
understanding
tilt the
of
jar
horizontal
like this.
orientation.
So you can't see the water, but I want you to find me a picture that shows what the water would look like in there. And put that, and when you find the right picture, put it over there.
Experience alone does not lead to knowing that water remains level. Understanding everyday experiences, such as the behavior of water in a glass, requires coordinating the movement of the glass with changes in the shape of its contents. Tanya's performance shows
that
she
picture
is
right?
capable of this
And
coordination.
why is that picture right?
Because it's slanted.
What's slanted?
The jar.
And what about the water? Is the water right? Is that the way the water is in here? Should we look and see? Okay, let's look and see. Were you right? Very good. Now I'm going to take these and I'm going to shuffle them all up, just like a deck of cards. Okay? Whoops. Get them all up here.
A general concept of horizontal
Just
allows Tanya to anticipate what is
make
and is
sure
not
that we're-
physically possible.
Getting all the stuff we want. I'm going to ask you to go through these piles again and put the right ones over here and the ones that are wrong over here. And why is that one wrong? Tell me why that's wrong.
Because the water can't be like that.
It can't be slanted like that, and why not?
Because this, there's nothing to hold up the water.
Okay, that sounds like a good enough answer. Very good, Tanya. Okay, I'm going to take one of these cards and I'm going to ask you a question about it. I'll take this one. Is there some way that you could tilt the jar to show how it would have to be for the water to be right in that jar?
Tanya rotates the card so that the water line is horizontal.
You would tilt it that way so the water would be right. And why would you tilt it that way?
The line would be even.
Even with what?
Again, we see clear evidence that the concept of horizontal orientation underlies Tanya's performance. An objective understanding of the spatial relationships between objects requires an understanding of how appearances change as we move about. To know objectively that a line is straight, one must realize that it will appear straight from all possible views. During the preconceptual stage, to which most 4- and 5-year-olds belong, the coordination of viewpoints is not possible and therefore not considered in the construction of straight rows. Nor is a comparison of viewpoints used as a test for straightness. During the intuitive stage, to which most 6- and 7-year-olds belong, children can form close approximations to straight rows. Further, when looking straight on, they can tell whether the line is straight. However, the importance of changing viewpoints is not yet part of their understanding. By 8 years of age, most children enter the concrete operational stage. Children in this stage realize the importance of different points of view in determining whether a line is straight. When asked to select a picture of what they see, preconceptual children choose any picture that represents the objects in view. However, they cannot analyze the spatial relationships between the objects. Children in the intuitive stage can analyze the spatial relationships seen from their own view. However, anticipating how those relationships will appear from other views is beyond their grasp. By the concrete operational stage, Children can anticipate how the spatial relationships between objects will appear from all possible views. To understand how objects will appear from all possible views requires a coordination between up-down, left-right, and foreground-background orientations. The development of this coordination is further revealed in the water level task. Preconceptual children cannot represent the water's surface or its orientation even when it is in view. Children in the intuitive stage can draw or select pictures that represent the water level as it is seen. However, the concept of horizontal orientation is not achieved by children in this stage. As a result, they are confused by the tilting sides of the jar and cannot predict how the water will look. By the concrete operational stage, children have developed a spatial reference system. An understanding of vertical and horizontal orientations is one expression of such a system. With its achievement, the child can give a more reliable interpretation to physical reality. An accurate prediction of the water level is one example. From birth on, we live in a world of objects located in space. An objective understanding of this space is acquired gradually and is generally not achieved until middle childhood. Prior to this, space is like a number of different pictures, not yet connected to form a single reality. By the concrete operational stage, the pictures are connected through a construction of a spatial reference system composed of left-right, foreground-background, and vertical-horizontal orientations. This system makes it possible to know with certainty how one's own view is related to the views seen by others.